Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over our unit on polynomials. All right, let's take a look at number one. It involves adding polynomials. So one thing you want to remember is that only polynomials that are like terms could be added to one another, okay? If the degree is identical, then that shows that they are like terms. So let's go ahead and add these two polynomials. We have a to the fourth plus 6a to the third plus a plus 4. Now, if you notice, I rewrote this polynomial in standard form with the degrees in descending order. Okay, now the second polynomial, I will write in the same format and ensure that like terms are aligned vertically because I'm going to be adding vertically. Okay, so the third degree term, I'll put it underneath the third degree term here, 4a to the third, minus 8a, which is the first degree term, plus 2. Okay, now we will proceed to add downwards. Now, when you're adding polynomials, you do not do anything to the degree. You just add coefficients. Okay, so here we just have a to the fourth. Since imagine there is a 0a to the fourth here, plus 6a cubed minus 4a cubed. You just subtract the coefficients. You have plus 2a to the third. And then this a right here, imagine as though there is a 1. So what you do is you subtract 1 minus 8, which is negative 7, and bring down the a, plus 4 plus 2 is plus 6. So our answer is option letter D. Okay, let's take a look at number 2. In number 2, we're finding a product. We're multiplying a quadratic trinomial by another quadratic trinomial. Now, when you're multiplying more than 3 terms or more than 2 terms, it's good to always use the box method or vertical multiplication. Distribution works, but I found it more effective to make use of alternative methods to distribution in multiplying polynomials with 3 or more degrees in the factors. Okay, so using the box method is pretty straightforward. What you do is you just align these two factors vertically and horizontally. Let's take the first one. Align it horizontally. We have 6n squared plus 2n plus 4. Now each of these terms will form my row, okay, according to their degree. And then I'm going to take the second factor and orient it vertically. All right, so we have 2n squared minus 4n minus 2. Now what we've created is a multiplication grid. And this multiplication grid will help us stay organized while we're multiplying and also to help us to find the final result. Okay, so 6n squared, this is a square column. This is a first degree column. And this is a constant column here. Before we start, a real quick review on the product property of exponents. When you're multiplying exponents of the same base, x to the a times x to the b, you add the powers. Okay, so you have x to the a plus b. That's how you resolve that. If they have coefficients, you multiply the coefficients, like ax to the a times bx to the b. You multiply the coefficients, a times b, and you add the powers. All right? Okay, let's go ahead and do this. So 2n squared times 6n squared, 2 times 6 is 12, n to the 2 plus 2, which is 4. 2n squared times 2n, 2 times 2 is 4, n squared times n. Imagine this is n to the first power. Okay, so you add the powers, you have n to the third. 2n squared times positive 4. Imagine there's an n to the 0 here. 2 times 4 is 8n squared, because 2 plus 0 is 2. Negative 4n times 6n squared, we have negative 24. N to the third. Negative 4n times positive 2n, we have minus times plus is minus. 4 times 2 is 8. N to the, there is a 1 here, 1 plus 1, 2. minus times minus, minus 4 times 4 is 16n. Okay, and then negative 2 times 6n squared, we have negative 12n squared. Negative 2 times 2n, we have 2 times 2, which is 4. Minus times plus is minus, minus 4n. Negative 2 times 4 is negative 8. Okay, so let's go ahead and combine like terms. We have only 1/4 degree term here, so we'll bring that down. Positive 12n to the 4th power. And then if we think about third degree terms, there are 2 of them right here. Combine those 2. Now when you're combining, remember we're just adding coefficients, okay? So negative 24 plus 4 is going to be negative 20n to the 3rd. And then the next diagonal happens to be our second degree terms. So if we add these terms together, we're going to have, notice these two are opposites. So if you add both of them, you get 0 minus 12n squared. There is a minus over here. Let me just highlight it so you can see it clearly. And then first degree terms, we have negative 16n and positive 4n. They're like terms. Combine those two, we are going to have negative 20n. And then we're left with our constant right here, negative 8. It has nothing to be combined to, just like 12n to the 4th. So we have minus 8. Our correct answer is option letter C. All right, let's take a look at number 3. Number 3 involves division of polynomials. So if you take a look at this polynomial right here, our dividend is, our divisor is of the first degree, and a is equal to 1. So whenever you have a situation of this format, like this, where you have a divisor that is x plus r, it's quicker to use the synthetic division algorithm to divide. Okay, so that is what we're going to be doing here. So the first step in the synthetic division algorithm is to ensure that your dividend has no missing degrees. Okay, if any degrees are missing, then you will have to put in a divisor. Okay, we'll put in a placeholder. So we have no missing terms. If you have no missing terms, there is no need for a placeholder. Okay, so we have 4, 3, 2, 1, and x to the 0. Nothing is missing. Perfect. So what we're going to do, since there are no missing terms, let me just rewrite it. We have x to the 4th plus 3x to the 3rd minus 64x squared plus 67x plus 79. What I'm going to do is I'm going to extract all the coefficients of each term. Okay, now the first term has no number, so we put in the invisible number 1. That will be the first coefficient to be extracted. So we have 1, 3, negative 64, 67, and 79. Let's create our synthetic division bars. It's like an upside down division bar. And then we're going to place our coefficients inside. 1, 3, negative 64, 67, and 79. Now, this is another part where you want to be extremely careful. You do not just take this number 10 and place it right here. You have to find the root of the divisor. Okay, how do we find the root of the divisor? You set it equal to 0 and solve for x. That tells you the root. Okay, so you subtract 10 from both sides. Negative 10 is what goes outside of our synthetic division bars. Now to finish this off, we're simply going to add down and multiply across repeatedly until we get to the final column. Okay, all right, so let's go ahead and get started. There is no number here, so we put in 0. And then we're going to add down. 1 plus 0 is 1. And then we're going to multiply across. So this 10 times this goes here. So negative 10 times 1 is negative 10. And we're going to proceed to add down again. 3 minus 10 is negative 7. And now we're going to repeat the same iteration, the same procedure again. We're going to keep adding down and multiplying across over and over again. All right, so if we multiply across, we multiply 10 times negative 7. The result is going to go right here. So multiply. Negative 10 times negative 7 is 70. Okay, so we're going to add down. When we add down, we'll end up with positive 6. And then we're going to multiply across again. After adding down, of course, we'll multiply across. Negative 10 times positive 6 is negative 60. And we're going to add down again. Positive 67 times negative 60 is positive 7. And then we're going to multiply across. Negative 10 times 70 and put the answer underneath. 79. Negative 10 times 70 is negative 70. And then we add down. And then when we subtract these two, we get positive 9. All right, and we put a line here to indicate that the last term is not part of the coefficient of the quotient, but just the remainder. These four terms here are the coefficients of the quotient, or is also known as the depressed polynomial. All right, so we're going to have 1x to the, now since this divisor has a degree of 1, when we divide the dividend, a degree of 4, by a divisor with a degree of 1, the degree here decreases by 1. Think about this. X to the 4th divided by x to the 1st power becomes what? X to the 3rd. Okay, so all these degrees decrease by 1. Okay, so we're going to have 1x to the what? 3rd. And then you descend until you get to 0. Okay, negative 7x, extract that coefficient to the 2nd power plus 6x to the 1st power plus 7x to the 0th power, that's just 7. And then we have our remainder, which is 9, plus 9 over the divisor, which is x plus 10. Okay, so our answer is option letter B. All right, let's take a look at problem number 4. For problem 4, we had to expand this binomial here. So let's just put in a side note. The task is to expand completely. Now, if you are multiplying a binomial raised to the 2nd power, it's good to just, you can use the box method or you can just distribute or FOIL it out. But when the degrees are 3 or higher, there is a much more effective method, and that is Pascal's triangle. Okay, so now we have a plus b to the 4th power. We're going to be using Pascal's triangle here. Now, since the power of the binomial is 4, we're going to create our Pascal's triangle all the way to row number 4. All right, so let's go ahead and do that. So we have 1, 1, 1. Now, what rows of Pascal's triangle are these? This is row 0. This is row 1. How far are we going? We're going all the way to row 4 because that's the power that is binomial expression is being raised to. Okay, so 1, 2, 1. Remember the procedure for creating the Pascal's triangle is you have 1s on the exterior, and then you add, to get the number underneath, you just add the 2 numbers on the top. Okay, so 1 plus 1 creates 2. The bottom middle is generated by adding the 2 on the top. All right, so you have, this is row 2. right here. And we have 1. Remember, you always have 1s at the end. To get the number beneath these two, we just add them. 1 plus 2, 3. The number here is a sum of 2 and 1, which is 3. This is row 3. Okay, one more. Start with 1s. You always have 1s at the end. And then to get the bottom middle, you add the 2 on top. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And there's always symmetry in the rows of Pascal's triangle. 1, 1, 4, 4, 6 in the middle, 3, 3, 1, 1, 1, 1, 1, 1. Okay, so you can always take advantage of that symmetry to check the accuracy of your rows. Okay, now we have a component of the coefficients. So what we're going to do is we're going to extract row 4 and orient it vertically. Okay, so 1, 4, 6, 4, 1. Now we're going to take the first term of our binomial, which is a, and we're going to place it here. For every number from Pascal's triangle, we're going to place an a next to it. A, 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 A. And then we'll take the second term plus b, and then we're going to place it next to a. Okay, so we have positive b, we can just put b, that's fine. If it were negative, that will alternate the sign of our expansion, so we have to include that also. All right, my positive doesn't change with the variation of the degree that the term is being raised to, so it's not necessary to include that. Now we have to attach powers to our terms. So a starts with the highest power. Okay, so a is going to go 4, and then it's going to descend all the way to 0. So 4, 3, 2, 1, 0. And guess what? B starts from 0 and ascends all the way to 4. All right, so 0, 1, 2, 3, 4. Another way to check to ensure that your powers are correct is that the sum is always 4. 4 plus 0, 4. 3 plus 1, 4. 2 plus 2, 4. 1 plus 3, 4. 0 plus 4 is 4. All right, so now we're just going to proceed to multiply it out. So that will give us the terms of the expansion of this binomial raised to the 4th power. Okay, now remember, every term other than 0 raised to the 0th power is just 1. So this is 1 right here. And that one, this one also is just 1. Okay, so we're going to have 1 times a to the 4th. 1 times a to the 4th, which is simply a to the 4th. Let's see, 4 times a to the 3rd times b, which is just 4 a to the 3rd b. And then the next expansion, we have 6 times a squared times b squared, which is 6a squared b squared. 4 times a times b to the 3rd is 4 times a to the 1st b to the 3rd, which is 4ab cubed. And then the last row, 1 times 1 times b to the 4th is just b to the 4th. Okay, now when we just add these terms horizontally, just add them up, that will be our expansion. Okay, so a plus b to the 4th is equal to a to the 4th plus 4a to the 3rd b plus 6a squared b squared plus 4ab to the 3rd plus b to the 4th. All right, correct answer is option letter B. All right, let's take a look at problem number 5. We have a quadratic equation here. We are to find all the roots. So we have 5x squared plus 9x plus 4 equals 0. We notice that our options are all rational numbers, so that's an indication that this quadratic trinomial is factorable. Okay, whenever you want to solve factorable quadratic equations, you always want to use the X game or factoring by grouping. Okay, there's no need to use a quadratic formula here, except you're very efficient at it. Remember, the quadratic formula always works, but factoring by grouping is only applicable to factorable quadratic equations, which is the case here. Okay, so to factor this, we have AC on the top, B on the bottom. This is A, this is B, coefficient of the middle term, and this is C, as long as the polynomial is written in standard form. That is the case here. The degrees are in descending order, so we have A equals 5, B equals 9, and C equals 4. All right, AC is 5 times 4, which is 20, B is 9. So now what two numbers multiply to give you 20 and add to give you 9? 5 times 4 fits the description. Let me alter the color of those two numbers there. So 5 times 4. Now we're going to replace the middle term with these two so that we can have a quadratic with 4 terms that can be factored by grouping. Okay, so we have 5x squared plus 5x plus 4x plus 4 equals 0. And then you're going to break it down the center in front of the sign and factor by grouping, okay? From the first two, you can take out 5x. So you're left with x plus 1. For the next two, we can take out the GCF, which is 4, and we have x plus 1. We'll do a quick check. Are the two quantities in the parentheses identical? The answer is yes. That is great. That means that our steps so far are correct. All right, now we're going to factor out the common factors, namely x plus 1 and x plus 1. So we have x plus 1. And what's left is 5x plus 4. Those will be grouped together in their own parentheses, equals 0. Now we're going to use the zero product property to finish this off. You set the first factor to 0 and the second factor to 0. Okay? First one we can solve using algebraic procedure. Subtract 1. We have x equals -1. That's the first root. The second one, we subtract 4. That yields 5x equals -4. Divide both sides by 5. And that will give us our final result. X equals -4 over 5. So our roots are what are our roots? In ascending order, -4 over 5 and -1. Option letter B. All right, let's take a look at number 6. And then we're going to take a look at, we're going to start part 2 after taking a break. So number 6, we have 125 x to the third minus 8. We're asked to factor these two numbers. Factor this equation right here. Now, if you examine the two terms that we have, you notice that they are what? These numbers, 125 and 8, and this variable x to the third are all cubes. Okay, so if you have your cubes memorized, that will help you to easily see that 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is what? 8. See that right there? 8 is a cube. Let's take a look at the next number, which is what? 5. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is what? 125. 125 is a cube, and x to the third is a cube because we see that 3 there. All right? So since we're dealing with a difference of cubes, we're going to use the difference of cubes factorization formula. The difference of cubes factorization formula is as follows. It's a cubed minus b cubed equals a minus b. The first sign is always the same. and then it's always the same as the sign between the original problem. And then we have a square ab b square. Now what signs go here? The next sign is always opposite of what we have here, which is plus, and the last is always positive. Okay, so we have the acronym SOAP happening here. First sign is always the same. Second one is opposite for O, and then the last one is always positive. All right, so that's basically how you expand difference of cubes. And guess what? The same pattern applies to the sum of cubes. Let's just put that there just for informative reasons. So a plus b, a squared. So this is the same. The next one is opposite, minus. And the last one is what? Always positive. So that's a nice little pattern to help you remember this formula. Okay, so in order for us to do this problem, we just need a and b and the formula, and we are good to go. All right, so we have to find a. Now the first term here, 125 x to the third is equal to a cubed. Okay, or we can write it as a cubed is equal to 125 x to the third. So what is a? How do we get a? We have to undo the cube, right? The inverse of cube is cube root, so we take the cube root of both sides. All right, and write that again. Take the cube root of both sides. So the cube root of a cubed is a. The cube root of 125, remember we talked about 5 to the third power is 125. So it follows that the cube root of 125 is what? 5. Okay, and x to the third raised to the 1/3 power, the cube root of x to the third is just x. All right, so that's our a right there. A is 5x. Next thing we need is b. Okay, so b to the third is the second term. B to the third is 8. Forget about the sign. Okay, to get b by itself, you take the cube root of both sides as we did with a. Cube root of b cubed is b. What is the cube root of 8? Since 2 to the third power is 8, it follows that a cube root of 8 is 2. All right, so let's rewrite the problem. We have 125x to the third minus 8. Now, the formula that we're using is, let's put it on top, a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay? All right, so a plus b, what is a plus b? A is 5x, b is 2, so we have 5x minus 2 times a squared. A squared, let's see what we have there. We have a is 5x. We are squaring both the 5 and the x. That is why I'm grouping it in parentheses, okay? And then a is 5x times b, which is 2, plus b squared is just 2 alone, so I can just put 2 without any parentheses since it doesn't have another component being multiplied to it. So just simplify this resulting expression on the right, and that will be your final result. Okay, so we have 5x minus 2 times, now you have to be careful here when you're squaring 5x squared. You're going to square the 5, which is 25, and square x squared also. You square both terms in the parentheses. Okay, that's the power of a product property of exponents. Here we have 2 times 5, which is 10x, plus 2 squared, which is 4. 5x minus 2 quantity times the quantity 25x squared plus 10x plus 4. Option letter E is our correct answer. Thanks so much for taking the time to watch this presentation. We hope that this tutorial was beneficial to you. If you have any questions or need any support on any of the contents covered, just post your questions in the comments section below, and we'll be glad to support you as soon as possible. Do not forget to subscribe for part 2 of this review series. Do give us a thumbs up if you found the contents of this tutorial beneficial. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.